to look at was the notation that we used yesterday for x-intercepts, k pi. Okay, I got a lot of negative feedback about that. But let's just talk about the sine x, y equals the sine of x, basic graph. We're going to just do, I don't know, we'll do a few things. What does the sine of x do? What's the sine of 0? 0. And then it goes up, down, down, up, up, down. So the sine of x looks like this. Every time. Okay? The period of the sine function, this is a memorization fact. What's the period of the sine function? 2 pi, right? You got to memorize that. Now, I wanted you to discover it on that graph we did, and you did 0 to 360, and then it starts over. So that's one period of the sine function, which means from right here to where it starts over, is 2 pi. Half of that value is going to take us right there to the half of a period would be pi, right? And if we half that again, that's pi over 2, which is going to make this value 3 pi over 2, 5 pi over 2, 3 pi. And some of you are really struggling with that because you can't do fractions on the fly. I can't really help you with that a lot other than you just got to practice it. Right. But when you get to this point where you divide the period, you get pi there, you half it again, you get pi over 2, then that tells you that each one of these little hash marks that we're working with is pi over 2. So if I wanted to count by pi's over 2, if I want to count by pi over 2, the first one is pi over 2, the second one is 2 pi over 2, the next one is 3 pi over 2, the next one is 4 pi over 2, the next one is, y'all with me? And the next one is 6 pi over 2, and it just continues. And then these would simplify, of course, to be pi, 2 pi, 3 pi, etc. But we're counting by pi over 2. All right? Now, the thing that gave people pause yesterday was how do we express the x-intercepts, right? Here's my x-intercepts. Got an x-intercept there at 0. There's one at pi. There's one at 2 pi. There's one at 3 pi. So the pattern is firmly established, right? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. And if I went the other direction, it would be negative pi, negative 2 pi, negative 3 pi, etc. So we said that's the integer multiples of pi. We don't do anything in mathematics. Well, we do some things, but in math, we generally are going to have a notation for everything. That's too much words to write. So we're going to say that the integer multiples of pi, the way we would express that is k times pi, where k is an integer. Right? What are the integers? Not the counting numbers. Those are whole numbers. Natural numbers, I'm sorry. Natural numbers are the counting numbers. 1, 2, 3, 4, 5. The integers are the whole numbers and the opposite of the counting numbers. So it's the number line numbers, right? If we negative 3, negative 2, negative 1, 0, 1, 2, etc. That's the integers. All right. So this notation right here, k pi, where k is an integer, is this set. If we just added a pi to all these things, then that's what we've got. K pi, where k is an integer, would just say, well, that's negative 3 pi, negative 2 pi, negative 1 pi, negative 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, forever in both directions. Because the trig graphs just bounce around forever in both directions, and they never vary from their pattern. So that was k pi, where k is an integer. These are the x-intercepts of the sine function. If you don't understand the notation for the test, memorize it. It's just one thing, right? And the other thing was the x-intercepts of the cosine function. That was the odd multiples of pi over 2. And I don't care if you write odd multiples of pi over 2 on the test. You could write that. You don't have to know and understand the notation. I do want you to know the deal. Okay, I want you to know where the asymptotes of the tangent function are, because those asymptotes are a guide to graphing it. Where the asymptotes of the tangent function? Where cosine is equal to 0. So again, that's the odd multiples of pi over 2. So those are the things that we need to know. All right? Again, if you need help with the first five problems or first 6 problems, you'll need to come see me and we'll talk about that individually. But the next 3 of the homework problems we're going to work together. Okay? So what were they? What was the first one? 15. Y equals 2 sine of 4x. I want everybody to engage here, okay? 2 sine of 4x. I always ask my wife for advice as a teacher because she's just a better teacher than I am. And she helps me. And I went home last night and I was a little bit disappointed myself, a little bit. I wasn't disappointed with students, but I was worried, concerned that a lot of you are struggling with this. And she reminded me that this is the spring semester of your senior year, and this is the first time you've done anything this difficult in a long time. Senior year's pretty easy, right? Except for college trig. I get to teach that class. So, hey, don't quit. Don't give up. But remember, this is not a cakewalk. This is not college algebra. All right, here we go. We're going to graph this the way we always graph the sine function. The sine function is always going to look the same. Starts at what? Sine of 0 is 0. You can get that value right there from the table if you forget. Sine of 0 is 0. What does the sine do? Goes up, down. It just bounces between 0, 1, negative 1, 0, 1, negative 1, 0, 1, 0, negative 1. Sorry, I forgot the zeros in there, but it just bounces back and forth like that. Okay, now this graph has 2 transformations. It has an amplitude change, and it has a period change. So here's my amplitude change. Instead of bouncing between 1 and negative 1, what the sine graph normally does, this one is going to bounce between 2 and negative 2. Okay? Is that good, Sarah?
I'm confused about when it says negative pi is less.
Yeah, I tried to remember to tell you to ignore that.
Okay, so we don't pay attention.
Yeah, I don't want you to do that. We're just going to sketch the basic graphs. But what that means is that they want you to sketch that much of it. They want you to go that far to the left and that far to the right. My premise is if you can graph a little bit of it, then you can put it anywhere, right? So I just want you to know the basic shapes and starts. I thought I told you in class, maybe I didn't tell you to ignore those domains that they give you. When you get to calculus, they'll give you a domain for the trig function that you're working with. You got to pay attention to that, but that's not my goal for this portion of the class. Just want you to understand the shapes of the graph, basic transformations. So this one has an amplitude change of 2. What does this 4 affect? The period. That's the b in the a sine of bx plus c. So that's b. The period is 2 pi divided by that value. So my period here is 2 pi divided by 4, which is pi over 2. What that means is, from my starting point to where I start repeating myself, is pi over 2 wide. I'm going to half pi over 2. You should be able to do that quickly in your head at this point. Half of pi over 2 is pi over 4. Half of that is pi over 8. Now that tells me that my axis is divided into pi over 8 little increments. So I got 1 pi over 8, 2 pi over 8, which simplifies to be pi over 4, 3 pi over 8, 4 pi over 8, which simplifies to be pi over 2, 5 pi over 8 would be my next one. And if I went this direction, that would be negative pi over 8. So Sarah, if I wanted to continue this in either direction, they said they wanted to see from negative pi over 2 to positive pi over 2. That means they wanted you to stop your graph here and go all the way to negative pi over 2 in that direction. And you could continue that pattern once you establish the first one. I'm not interested in that so much. I'm not interested in specific domains. That's what they were giving you, was specific domains. Okay? All right, any questions here before we move to the next one? All right, what's the third one? What was that, the first one? Y equals 1/3 cosine of 2 pi x. What function are we graphing here? Cosine function, right? Just the regular old cosine, not the negative cosine, anything like that. Where does the cosine always start? Maddie, you getting this? Where does the cosine always start? Cosine 0 is 1. It's going to go down, down, up, up, down. And it just continues doing that over and over, bouncing around, up and down between its peak and its low point. Okay? Now I need to label the graph. This one has a amplitude of 1/3. All right, so this is going to be 1/3. This is going to be negative 1/3. It's going up 1/3, down 1/3. The period, okay, again we have a cosine of bx. The period is 2 pi divided by b, 2 pi divided by 2 pi in this case, which is 1. And that's odd. 1 radian, 57 degrees roughly. So this thing is going all the way through one period in 57 degrees instead of 360 degrees. Why? Because it's being multiplied by pi, which is 6.28 roughly. So we would expect it to go through its period 6 times faster. Well, that's about 60 degrees. 57 degrees is what it is. All right. So from where it starts to where it starts over is 1. Holt. Half of that is 1/2. Half of that would be 1/4. So this axis is labeled in fourths. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, etc. And that one is done. Getting better? Seeing it again? Step by step. All right, let's do the last one, and then we're going to cover our lesson today, which is vertical shift and horizontal shift. It's not that difficult. It's the same thing. Right? What's the third one? Or was that it? Did we do all the homework problems? What was the third one? Caitlin, what is it?
Y equals negative 1/4 sine of
X over 2. Now this one is going to require us to do something at the beginning that's a little different because of the negative, right? What does the negative sign do? It changes the orientation. So instead of starting at 0 and going up, the sine function is going to start at 0 and go down. But everything else is the same. We're bouncing around between these two values. So it starts at 0. Instead of opening up, this one's going to open down. And then it's going to bounce up and down. So this graph looks like this. It's going to go up over here like that. The amplitude is 1/4, which means it's bouncing between 1/4 and negative 1/4. The period is 2 pi divided by 1/2, which is 4 pi. That means from where it starts to where it starts over is 4 pi. This one's actually easy to label because it's easy to half these. Pi, 2 pi, 3 pi, 4 pi, 5 pi. How about k pi, where k is an integer? Go Tigers. Beautiful colors. Just reminds me of that.
Where's Zach recovering?
Do what?
Is Zach absent today?
Is that what?
Is Zach absent today?
Zach who?
Montgomery.
Yeah.
I haven't seen him today.
All right. Any questions there?